So, a really critical AI benchmark has just been shattered. But here's the thing. The big story isn't some revolutionary new model, which is probably what you're thinking. No, it's the revolutionary new method that was used.
Okay, let's just get right to the facts. We're looking at a GPT-5 class system hitting 75% accuracy on the ARC-AGI-2 benchmark. Now, to put that in perspective, the average human scores around 60%. So yeah, this isn't just a small step, it's a major, major milestone.
But, and this is absolutely crucial to understand, the base model didn't pull this off on its own, not even close. The real breakthrough came from the system that was built around it. And honestly, if you want to understand the real pace of AI progress right now, this is the key.
So to really get why this is such a big deal, we have to look at the benchmark itself. You see, ARC-AGI, it's not your standard run-of-the-mill test. It was engineered from the ground up to be different, to be hard.
It was designed specifically to measure what's called fluid intelligence. You know, the ability to reason through totally new problems you've never seen before? It's built to resist simple memorization or pattern matching. In fact, that's why in the first version of this test, it was pretty common for early AIs to score a flat 0. That's how tough it is.
And you know, the consensus among experts was pretty clear. To get past this benchmark, we'd need a whole new generation of models, a huge leap in just raw brute force capability. But as this result proves, that assumption was just plain wrong. The performance gains came from somewhere else entirely.
And that somewhere else? Well, it's a concept called unhobbling. It's this idea that we can unlock the intelligence that's already inside these models just by removing the artificial constraints we've been putting on them.
You know, this isn't totally out of the blue. In his paper, Situational Awareness, Leopold Aschenbrenner, who used to be at OpenAI, he basically predicted this exact thing what happened. He made this brilliant point that we were forcing these models to give us an instant answer, instead of giving them the space to actually, well, to think.
This really shows you the difference perfectly. On the one hand, you have the hobbled approach. You give it one prompt, you expect one immediate answer. And for complex stuff, that just fails. But then you have the unhobbled approach. This allows for step-by-step reasoning, kind of like using a scratch pad to work out a math problem. This is the whole idea behind techniques you might have heard of, like chain of thought prompting.
Okay, so how does this actually work in practice? Well, the company Poetic built what they call a manager system that wraps around the base model. So instead of just asking the model for an answer, this system acts like a project manager. It deconstructs the problem, it selects the best tool for each little subtask, it even writes code to help its own reasoning. And then it double-checks its own work. It's incredible. It basically turns this messy, fuzzy process of reasoning into a super controlled, efficient workflow.
And I want to be clear, this is not just some one-off trick. All the data we're seeing shows that this kind of system-based approach, it's quickly becoming the new paradigm for squeezing every last drop of performance out of our AI models.
I mean, just look at this table. It tells the whole story. Look at these jumps in performance. A GPT-5 class model goes from being about average for a human to being superhuman. Then you have xAI's Grok 4 getting this massive lift. And maybe the most dramatic one of all, Google's Gemini 3 Pro, it more than doubles its score. It goes from under 30% to over 60%. And the key is, this is all done without changing the core model one bit.
That 16-point jump for Grok 4 is really telling, isn't it? It proves that this unhobbling architecture isn't tied to one specific model. It's model agnostic. This is a fundamental improvement in how we talk to and structure our interactions with AI, not just some little tweak that only works for GPT.
So, okay, we've hit this incredible new level of reasoning. What's next? Well, the entire conversation in the field is now shifting. We're moving away from just solving problems we're given and towards something way, way more complex. True agency. Francois Chalet, the guy who actually created this benchmark, he gives us some really important context here. He's quick to point out that, yeah, solving these ARC problems is impressive, for sure. But it's still light years away from the kind of deep, long-term reasoning that defines the absolute peak of human intelligence. You know, like solving one of those Millennium Prize math problems.
And the difference between where we've been and where we're going is just stark. ARC-AGI 2 was all about static reasoning. It was basically, here are 3 examples, now solve the 4th. But the next version, ARC-AGI 3, is a whole different ballgame. It's about interactive agency. It's more like, okay, we've dropped you into a brand new world, figure out the rules, set your own goals, and then go achieve them.
So this next test of intelligence, it's going to be looking at a completely different set of skills. We're talking about exploration, about setting goals all on its own,
and about learning super efficiently in a world it's never seen. This right here is the missing piece. This is what separates really, really advanced pattern matching from what you might call genuine intelligence.
So what does this all mean for us, like in the near future? Well, here in 2024, we've clearly hit a huge milestone for reasoning. The forecast is that by 2026, ARC-AGI-3 will start seriously testing for true agency. And what that means is, by 2027, as these unhobbling techniques get even better, the AI you're interacting with is going to look a lot less like a simple chatbot and a whole lot more like an autonomous agent, or maybe even a coworker.
And all of this brings us to the final, and I think most critical question. We're getting these incredible gains just by building smarter systems around the models we already have. The performance we're seeing today is just unlocking potential that was already there, hiding in plain sight. So you have to ask yourself, what happens when the next generation of models, ones with far, far greater raw intelligence, gets dropped into these increasingly sophisticated systems? What happens then?